In section 4.4, we will take notes on factoring polynomials. First, define each of the vocab words. Next, look through the core concepts. Notice we will be factoring sum of two cubes and difference of two cubes. Remember, you already know how to do difference of two squares, and there is no such thing as sum of two squares. Here in the notes section of your journal, page 93, list some steps you want to use when trying to factor a polynomial. Now let's begin with example 1, which is factoring each polynomial completely. Completely means once you factor, try and factor again and continue factoring until all of the products are unfactorable. You should always try for a GCF first, and in example 1a we have a GCF of an x. So we're going to take an x out from each of the terms. We'll be left with x squared minus 4x minus 5. Now look what is left and decide if that is factorable. It looks like an easy trinomial, so I'm going to try that. X and x. Factors of 5 are 5 and 1. To make a negative 4, I need a negative 5 and a positive 1. And looking at what I have left over, they cannot be factored again, so I have now completely factored. Let's try B. GCF looks like a 3, and we can even take some y's out, 3 of them. What I would have left would be y squared minus 16. In the parentheses y squared minus 16, check to see if that can be factored again, which it looks like it's a difference of squares, y minus 4, y plus 4, which those cannot be factored again, so we are finished. In example C, GCF looks like 5z squared. Taking a 5z squared out, we're left with z squared plus 6z plus 9. Looking at what I just wrote in parentheses, this looks like a perfect square trinomial, which can be vectored to z plus 3 all squared. Now take a moment to try the monitoring progress. Let's look at example 2, factoring completely. It looks like in example 2a, x is cubed and 125 is also a perfect cube. It's 5 cubed. So we have a difference of 2 cubes. And the difference of 2 cubes can be written as a's and b's. So we'll do a minus b, and then we are going to square and multiply a and b together, and then square the b. And the signs are the same, opposite, and then always positive. So let's complete this with our problem, where a will be x and b will be 5. So basically cube root x cubed. What 3 times gives you x cubed? That would be x. What 3 times gives you 125? That would be 5. Now ignore the problem for a moment and let's square the x, multiply the 2 together, and then square the 5. The signs will be, the first one will be the same, opposite, always positive. And you are finished. The trinomial will not, this will never be factorable. Not factorable, so don't try. Let's look at the next example. In the next example, I don't recognize these numbers as being perfect cubes, but it looks like I can take a GCF out. My GCF, it looks like I could definitely take a 2 out and some s's, 2 of them. I would be left with 8s cubed plus 27. I do recognize 8 as being 2 cubed, s is cubed, and 27 is 3 cubed. So I now am left with a sum of cubes. So I'm going to carry down the GCF. Don't lose it. I'm going to make a small binomial and a big trinomial. Cube root of 8s cubed. So what 3 times will give me 8s cubed? 2s. What 3 times gives me 27? Then you're going to square the 2s. That would be 4s squared. Multiply the 2 together, 6s, and then square the 3, 9. Your signs follow SOAP. So the first sign is the same. The next sign is opposite. And the last sign is always positive. And this will be my factored form. We're going to pause here and we'll leave examples 3 and 4 for the next video.